Okay, thank you everyone for joining us. Uh, we will now start with our webinar on mass timber projects, building for the future while managing risk. I want to start by doing a land acknowledgement. The office of SBC are located in Takaranto, which translates from Mohawk as the place where there are trees standing in the water. Takaranto is the part of the tree lands and territories of the Mississaugas of the Credit, and is the traditional territory of the Anishinaabe, the Wendat, and the Haudenosaunee. Takaranto is within the territory lands protected by the Dish with One Spoon Wampum Belt Covenant, an agreement between the Haudenosaunee, the Anishinaabe, and allied nations to peacefully share and care for the resources around the Great Lakes. Today, Takaranto is home to many indigenous peoples from across Turtle Island. SBC is committed to truth and reconciliation and to honoring the Dish with One Spoon Wampum Belt Covenant. SBC gratefully acknowledges and expresses gratitude to be able to live and work in these lands. Uh, so this is our agenda for the day. I have a few things to share about Sustainable Buildings Canada and the work we are doing. And then we will hear from Catherine and Amelia at Blaney McMurtry. As always, I would like to share that we have lots of resources for new constructions, which can be found on our website using the link on this slide. As many of you know, we work with Enbridge on the Savings by Design program. So if you have any new projects, please reach out to us to see if we can help get you into the Savings by Design program. We also have resources for existing buildings. These can be found on our website. The link on this slide will take you to those resources. If you don't see something on our page that you think would be useful, please reach out to us. We're always looking to support research in the sustainable built environment. One of the things we're working on right now is the Better Condos Bootcamp. This is a one-day workshop for the key decision makers of a condo. We bring together condo owners, condo board members, and condo managers to learn how they can improve and future-proof their condos. I encourage you to go to the link on the slide to learn more about the program. We have sessions coming up this fall, so if you own a condo yourself or are working with condos, we highly encourage you to share this with them or to sign up yourself. Uh, as you're in this webinar, there are a few things about how you can engage as part of the webinar. We ask that you keep all your questions to the end, and then please raise your hand. You will be requested to open your mic, and then you can ask your question. After the webinar, we reach out to you with a link to the slide deck and the presenter's contact information. We store all of our webinars on our YouTube channel, which can be found at the link below. Once again, please wait until the end if you have any questions, and then raise your hand and we will call on you to open your mic. For this webinar, we will not be monitoring the chat for questions. So once again, you please raise your hand at the end of the webinar to ask your question. One last thing, the Mass Timber Costing Guide is another project we're working on funded by NRCan in partnership with RDH. In this, we are focused on mass timber as a potential structural building material for multi-unit residential buildings. If you have any examples of these types of constructions, finished or in progress, please send them to us. We're wrapping up on this shortly and it should be released soon. So now I'll pass it over to Adam to introduce our speakers.
Thank you, Diana. I'm happy to have our two presenters here today. As Diana said, we've been working on this mass timber costing guide for quite some time now, and some of the topics that continually come up in the research are things that we can't answer ourselves, and we are lucky to have an incredible network of adjacent experts, and in this case, Amelia Phillips Robbins is a member of the Sustainable Buildings Canada board, and so she recommended to us that maybe this is something that they could look into. So I want to thank Amelia for bringing up the topic, and Catherine DiMarco, her presentation partner here, and her partner at Blaney McMurtry, for both taking the time to investigate this for us and putting together this webinar. We're really looking forward to hearing the topics that you found in the legal considerations for mass timber buildings. And so with that, I'll hand things over to Amelia and Catherine.
Hi, good afternoon, everyone. Good morning for those on the West Coast. My name is Amelia Phillips Robbins, and I'm a senior associate in the construction law group at Blaney McMurtry. I have a pretty broad commercial litigation practice that specializes in contract disputes. I'm excited to speak with you today on mass timber construction projects, together with my colleague, Catherine DiMarco, who is an LSO certified construction law specialist. Kathy.
Thanks, Amelia, and good morning or good afternoon, everyone. As Amelia said, my name is Catherine DiMarco. I'm a partner in the commercial litigation group here at Blaney McMurtry. I practice almost exclusively in the construction and infrastructure law space, both on the front end, which is generally considered to be sort of contract drafting and contract negotiation, but also on the claim side, both in the pursuit and defense of claims in the construction context. And so we're lawyers, but this webinar is for informational purposes only and shouldn't be considered legal advice. So just to kick things off, thanks to Diana, we got a rundown on the sort of high level agenda for today. Can we go to the next slide, please? And we'll just talk a little bit more about, just briefly, a slightly more detailed agenda to kick it off. We're going to talk about what is mass timber. Then I'm going to talk about mass timber in the context of traditional contract delivery models. And then Amelia is going to talk about mass timber projects in the context of both IPD and P3 projects. We're not going to sort of read everything that's on the slide. We want to leave some room at the end for Q&A. So next slide, please. If just to kind of back up out of some of the weeds we're going to be getting into, just to kind of circle back on kind of exactly what a mass timber project is. So mass timber construction uses large prefabricated laminated wood panels, beams and columns and other structural components, including walls and floors and roofs. And those engineered wood products can be, there's a couple of different kinds. I don't profess to be an expert in sort of all the various kinds, but there is cross-laminated timber, there's glue laminated timber, and there's laminated veneer lumber that are intended to provide sort of strong and durable, fire protect fire resistance, particularly comparable with kind of concrete and steel. So mass timber is recognized for its sustainability features. It's using a renewable resource. The initial intelligence is that there's a reduced carbon footprint, and probably most importantly from the perspective of certainly owners, faster construction times following the manufacturing of the product. Now, mass timber relies on having access to the raw materials. It relies on having access to factory-based automation and the kind of skilled and knowledge workforce that has to come part and parcel with the factory-based automation, and fairly exacting tolerances. And the thing that sort of keeps coming up all the time when you read about considerations with respect to mass timber products or projects is the moisture content, like making sure the moisture content is correct in the first place, and then, as we'll talk about in a little bit more detail, kind of stays that way, like does not, for example, get exposed to elements that are going to impact the moisture content. In terms of kind of overall project coordination, I think fairly mass timber projects require earlier detailed discussion and coordination among the involved parties, like particularly because it's still not sort of very common in Canada. I understand that it's a little bit more common on the West Coast than it is in Ontario. So communication and more detailed coordination is probably quite key to keep a project kind of like on the rails and staying on the rails, and not kind of falling down at a relatively early hurdle, just because those early conversations didn't include some of the things that they should have included. And that, that group of people would include suppliers, it would include, the designers. Is there somebody different who's the offsite fabricator? How do all the logistics work? And I'm going to talk about that in a little bit greater detail in a minute. Certainly, particularly at the early stages of anything, risk is a key thing. So it's really important for the parties to identify the risks or the potential risks, and then ensure that the contract in question not only allocates the risk appropriately, but ensures that there are no gaps in risk, and that each side understands the risk that it's taking on. And, again, that risk needs to be identified and accounted for, drafted, allocated, and really understood within the context of the agreement, because not having that is going to result in certainly disputes and, maybe litigation or arbitration. Next slide, please. So just kind of at a high level, this is kind of an outline of, like a mass timber project itself. So if you look at kind of at the top of the slide where it talks about the optimized structural layout, using the prefabricated features to minimize the amount of on-site construction. And this is the other piece that you sort of keep coming back to as you read and learn more about mass timber projects, is the significant amount of work that happens off-site and sort of the manufacturing facility, not exactly like, but kind of similar to modular construction, where there's construction that goes on at a different facility that comes maybe potentially a storage, potentially via a storage area, but then gets to the site and then gets incorporated into the project site. So that's kind of one of the key pieces to that. And then you've got your kind of design bid build process, where the design and the construction may be assigned to a single entity, like you would have in a CCDC 14, or different other contract models. And I'm going to come to some of the sort of more commonly used ones in a minute. But the design build approach is kind of useful in projects where there is an overlap between the design and the construction phases. Not always going to be the case. And so, CCDC 14 is certainly an option, but not always necessarily, sort of the way to go, depending on the context of your project. So then again, the site work, so there's the manufacturing piece, and then the site work and the grading commence, under slab, electrical, mechanical. Then the slab on grade is poured and cured. Then the modular elements arrive on site and are sort of constructed, is not the word, I guess, erected and incorporated into the base structure. And that creates the sort of larger structure, the, kind of superstructure, after which the interior finishes get installed, as opposed to the traditional way where everything's like all the pieces are shipped to the site and everything's constructed and assembled on site. So after that, then, you prepare the design and engineering drawings, the as-built, for example, and then the other final, kind of finishing pieces. Can we go to the next slide, please? So certainly there are some pretty key advantages on mass timber products. You've got kind of potentially one source for the entire main structure design and the supply of the material. Prefabrication involves, probably a single material. You've got your lumber plus a variety of kind of bonding agents. that's the piece that gets done, off-site. So then you've got this off-site prefabrication piece. You potentially improve the risk of delay and the kind of compression of timeline that can sometimes happen, and can often happen when you've got off-site manufacturing, because that can go on at the same time as the structural elements that need to be built on site that are there for the prefabricated pieces to be shipped to the site. Certainly, I think there's broad application for mass timber projects, certainly suitable for low and mid-rise structure. This is probably true for other provinces, but in Ontario, there's quite a bit of construction going on in the like senior resident sector, and then also the student resident sector. And, quite likely, modular mass timber projects would be quite well suited to construct facilities such as that. The fabrication is certainly automated, highly, automated, and that, should, I hope, attract workers to the industry that might not otherwise consider employment in like a traditional construction trade. And those of us who worked in the industry a long time certainly see this dynamic as the older workforce are retiring, and we're not necessarily getting the younger generation as engaged in the construction world, because everybody has an idea of what that looks like, and they think it's wearing a hard hat and swinging a hammer on a job site. But it's not. You can be an architect, you could be an engineer, you could be, a specialist in prefabricated, modular mass timber, on the design side, on the fabrication side, on the installation side. So that you would think might pique the interest of people who might not always consider a career in the construction world. And then where things are automated, as things get refined, maybe newer, different kinds of materials, or newer, better ways of manufacturing, or newer, better ways of, erecting the superstructure on site happen, the automation should be easily sort of programmable, in the sense that it can readily adopt to new technologies that can speed production, make things more efficient, lower costs, and even sort of an increased number of applications in which the materials can be used. And then just kind of the last big one, I would say, are the environmental benefits. So mass timber, I think, is relatively commonly viewed as offering significant environmental benefits, reduced, carbon footprint compared to conventional building materials. Certainly, it's a renewable resource. And then the actual sort of production of mass timber itself requires less energy and water and stuff like that than materials like concrete and steel, leading to lower emissions, which is certainly a big driver in the modern world. Can we go to the next slide, please? So key things to consider is the time of year for the installation. You can manufacture inside, you can ship inside, you can store inside, but when it comes time to installing the mass timber at the project site, you've got to be mindful of the weather impacts. That's not unique to mass timber. Obviously, these weather considerations come into play no matter what kind of building materials you use. But again, the more you read about mass timber, the more you keep coming back to this moisture content. And so that's going to be, I think, a key, if not the key driver in some of the timing of the installation. Another piece is making sure that the on-site stuff, so the on-site foundation design and the slab on grade, incorporates the specific requirements for the types of anchors and installations that are needed to be able to get the sort of mass timber properly, A, delivered, but B, installed into the structure at large at the project site. Again, moisture protection of both the, the floor panels, the joints, the, roof panels, everything until the building's, kind of sealed and properly watertight. Fire ratings, acoustic requirements, these are all considerations that need to be taken into account. Some are not sort of squarely unique to mass timber, but it's just a slightly different way of approaching what are arguably sort of fundamental, conventional steps, other than, as you would see in modular, but other than, the offsite manufacturing and the shipping of materials, which is typically in like those, kind of flat pack type boxes to the project site. Can we go to the next slide? Actually, just skip one more to the traditional project delivery models. You know what? Actually, skip one more, and we'll jump to the CCDC slide. So most of you are probably familiar with the CCDC documents. That's the Canadian Construction Documents Committee. They're a national committee. They've been around since the 70s. On the committee are representatives from sort of across the industry, and they produce standard form construction contracts that govern construction project relationships and allocate the risk. And there are various CCDC forms of document depending on A, the contractual model, and then B, what it is you actually kind of hope to achieve. And the idea is to create sort of consistent and nationally recognized standard construction contracts to ensure that risk is allocated to the party who can most stand to bear that risk, reduces uncertainty, and then it provides kind of a common structural framework for the industry. Certainly that gets modified, for lack of a better word, through the use of supplementary conditions. And I'm sure we've all seen it, right? A CCDC 5B contract with 27 pages of supplementary conditions stapled to the back, which can upend or potentially completely upend the risk allocation. And mass timber is not unique in the sense that we still have to read your contracts carefully and make sure you understand the risk that you are assuming or potentially assuming, and that you've priced that risk. I think with the relative newness of mass timber projects, I think there's a higher risk of gaps, gaps in responsibilities, and or a party assuming risk that it doesn't realize it's assuming. So if we look, can we go to the next slide, please? If we go to so CCDC2, by the way, I think it was the first form of contract that the CCDC committee developed, and it's a CCDC2, so it's a stipulated price contract between an owner and a general contractor, and it's a relatively traditional contract model. So the owner enters into a stipulated price contract with the contractor. The contractor then enters into various subcontracts with whomever is appropriate, and then those subcontractors can enter into either subcontracts or supply agreements as they sort of go down the construction pyramid. It's your sort of typical design, bid, build model. There's a named consultant in the contract, but typically, so it's usually an engineer and architect, but there's a separate professional services agreement between the owner and the consultant, but the consultant is named and has the duties and obligations of the consultant that are set out in the CCDC 2. This is, I think, probably the most or one of the most widely used models in Ontario. It creates the sort of, processes and requirements, or it reflects the processes and requirements for full sort of design and construction, full design completion prior to construction, and then completion of the construction for delivery to, ultimately the owner. Can we go to the next slide, please? So just to kind of illustrate this in a little bit more detail, it's the, design, bid build type contract. So there's the planning, the owner selects a designer, usually engineer or architect, and then they prepare the designs. The designs are supposed to be completed. They're quite rarely completed. And then it goes to bid. The GC bids on it, and then the contract is awarded, and then the construction commences. And that's your typical sort of design bid build model. Can we go to the next slide, please? So also with respect to like a slightly more traditional model is the CCDC 5B, which is the construction manager at risk model, as opposed to the CCDC 5A, where the construction manager is an agent of the owner, and the owner enters into contracts with each of the various trades directly. In a CCDC 5B, the construction manager is at risk. They enter into the subcontracts and or supply agreements with the other parties down the construction pyramid. So the construction manager is typically engaged early. They often provide pre-construction services, costing, scheduling, constructability. And then once that's done, then they transition to effectively be sort of the general contractor to play that role during the course of construction. And so pricing is often like kind of a guaranteed maximum price or stipulated sum. If you look at the standard form, there's like kind of two pricing options, and one is struck out and the other one's filled in, depending on, sort of where the designs are and a number of other factors. This is a useful model where there's early contractor involvement, and cost forecasting are priorities. So can we go to the next slide, please? So I wanted to just touch a little bit on those two forms of those two CCDC forms of contract, because certainly, because of the age and the amount of time these contracts have been around, they are really prepared for and used frequently and with a great deal of success when you have like a sort of traditional construction model with the materials being delivered to the site and all of the construction work done on the site. So there's, again, as I sort of said at the beginning, you want to make sure in the new kind of world of mass timber that you've sort of like grabbed the thread at the beginning and pulled the thread right through to the end to make sure you've kind of thought all of the pieces through, and that you understand where the risk is allocated, and all of the other parties, could be and hopefully are doing the same thing, because you're going to get either sort of overlays or gaps when you have a mass timber project. So for example, and I would view this as a relatively important and big example, but you've got this off-site manufacturing of the mass timber materials. Well, almost guaranteed the manufacturer is not going to have space to store all the project materials. So like the mass timber once it's done being manufactured. So where is it going to go, right? Like who's responsible for getting the warehouse? Who's responsible for making sure that the warehouse has the correct moisture content? Who's monitoring the moisture content of the warehouse? Who's responsible to ship the materials once they're done at the manufacturer to the warehouse? How does that happen? Who incurs the cost? Who's paying for the shipping? Who's paying for the warehouse? Then once the base structure is done at the project, then you got to do it all over again, right? Somebody's got to pay for the, like, when does ownership change, right? Who pays for the truck? How does the material get shipped to site? Who's paying attention to the weather conditions? Who's paying attention to how much material can be delivered at a time? You maybe can't necessarily bring in, two 18-wheel trucks full of mass timber project if you've only got, X amount of labor force on site. You can't leave the materials exposed. There's a lot of construction materials that you can't leave exposed. It's not unique to mass timber, but again, somebody's got to be responsible for monitoring the moisture content and coordinating the delivery of the material so that it becomes this kind of just-in-time model of the transportation of them from the properly humidified storage facility to the project site. And so who's responsible for all of that, and who's responsible for making sure it happens, and if things go wrong, who's going to solve it? So who bears what risk at what stage? Maybe not necessarily a right or a wrong answer, but whatever the answer is, it's got to be baked into the contract now by way of supplementary conditions. I don't know if we forecast in the future, maybe ultimately there's going to be a CCDC form of contract that will be sort of uniquely tailored to mass timber projects. Certainly, we're not there yet, although I understand there have been some discussions. Right now, we just sort of have the contracts we have, and we'll deal with them as best we can. But again, like, it's just the ongoing question you have to keep asking is, who bears the risk at each stage, right? The risk of the cost, the risk of the loss, and the responsibility to make sure it gets done. So, and then that often also involves other owners. So the owner of the transportation company, the owner of the storage facility, the owner of the next transportation company, if it's different. So then that's one big example in my view. So then mass timber also requires a fair bit of like pre-planning in terms of specifications and fabrication, because it's not a sort of a model where things can be moderately designed and built at the project site. It has to be manufactured and come to the site able to be sort of unpacked from the flat pack and then just inserted into the slab on grade, or the foundation at the project site. Then weather delays, or again, this ties back to the moisture content, but also like other other considerations. A delay, for example, with weather risks. So the panels need to be protected from moisture. Who makes the decision about whether the weather conditions are suitable or not? Who bears the cost of the materials sitting in the warehouse longer than they maybe ought to have been, of the standby cost for the transportation? Like, these are all, like, the example I gave is like, just grab the thread and pull it to the end, and think about who's liable for what. And so I think building in a robust sort of pre-construction piece to your contract that needs to account. And then the other piece to this is potentially long lead times for delivery of materials to the manufacturing facility in the first place. And so if there are kind of material ordering windows, or if the manufacturing facility says, look, we need all of the raw materials here by January 15th, and if so, great, you can have this 3-month production window, but you don't get a production window beyond that because we've got another project. I mean, that could pretty significantly upend the timeline of a project. So these are all considerations that need to come into play in a mass timber project. So we'll go to the next slide, and Amelia is going to talk about integrated project delivery and P3 projects as they relate to mass timber projects. And I think we'll probably have a few minutes for Q&A at the end.
Thank you, Kathy. Yes, so let's move on to the IPD model. Um, unlike traditional construction project delivery models where design and construction are often sequential, as Kathy was discussing, the design bid build, IPD brings together the owner, consultant, and contractor, as well as others, to collaborate from the project's inception. There are a few key features of the IPD, so I'll talk about what those are. The first one is one multi-party agreement. So all key participants sign a single contract, allowing early involvement of all of those people, all of that key expertise, right at the beginning to improve theoretically constructability, cost control, and scheduling. Another key feature of the IPD is shared risk, shared reward. There is a shared profit and loss pool uh, in an IPD project model that is supposed to ensure financial outcomes are tied to the IPD team's collective project performance. It's supposed to incentivize the team to work together collaboratively to meet or exceed their project goals. Another key feature is collaboration and joint decision making. So key decisions are made jointly, leveraging kind of the diverse expertise around the table of the entire team, from project design right through to the completion of construction. Everyone's involved. So for example, your mass timber supplier may be able to sequence deliveries to allow for just-in-time delivery, depending on the progress of the construction on site, because they're at the table with the installers. Or another example, an installer may be able to store your material until installation of specific panels because they're at the table right from the beginning. Another key feature of the IPD is open communication and transparency. Kind of full visibility into the project's information, including its financials, is a key feature of the IPD. So it's supposed to build trust and support informed, timely decision making. Open, transparent communication also keeps everybody in the loop and on the same page. And it's really the cornerstone of an IPD model. It requires an information sharing platform so that the whole team can collaborate, weigh in towards assisting each other with achieving the project's goals. So in terms of an information sharing platform, you may have heard of a BIM platform or a building information modeling platform that is recommended and can be used to provide a shared digital space where everyone can view and manage the project. There's also something called the big room, or known as the big room, in the IPD, where all main project participants can conceive of, they can design, execute the project from the same physical or virtual workspace. This is known as the big room. The big room is meant to encourage communication, collaboration, real-time problem solving, and also foster a built-in feedback loop. Everyone is there. Everyone is in the big room at the table. The big room also contains everything that the team would need to work together productively. So it would have, theoretically, it would have whiteboards, wall charts with the project's financials, with the project's schedule. It would have status updates, mock-ups, printers, that sort of thing. Another key feature of the big room is that egos are supposed to be left at the door. We'll get into that a little bit more in a few minutes. Another key feature of the IPD, there's a no-fault approach under this style. So the IPD team agrees not to sue each other, essentially is what that comes down to. And it's supposed to allow them to remain focused on solutions rather than assigning blame when errors or mistakes happen. Certain exceptions, of course, exist. If there's willful misconduct, if there are, significant hidden defects that don't get discovered until after the warranty period, things like that. But in the normal course, the no-fault approach is supposed to optimize results for the whole table instead of individual parties. So, for example, if there is a design team, if a design team member, drops the ball, there wouldn't be a discussion that kind of goes like this. Well, you dropped the ball, design team person, so you should pay me X dollars for dropping the ball. In the IPD, all team members are accountable for the design and for the quality of the execution. So you've pooled all the profits. And so if a ball is dropped, it's not going to come out of the pocket of the design team member necessarily. It's going to come out of the whole team's pool. So everyone is rallied and accountable for the whole design. And that's the idea of the IPD. So you've got an integrated team with integrated technology, say, for example, in the BIM, with an integrated location in the big room, integrated communication, kind of all towards a shared overall goal and a shared wish to meet sub-goals for everybody at the table at its relevant phase. And even to meet specific goals within that that make up the phase of the phases of an IPD project. So when it comes to phases, that takes us to the next slide, I believe. I want to talk to you about a specific CCDC contract called the CCDC 30. It is the IPD contract from the CCDC. So the CCDC 30 is a single multi-party contract that contemplates execution by the folks at the table that you saw on the last slide. Including the supplier and manufacturers. Kathy mentioned, suppliers and manufacturers are key parties in an IPD, or rather in a mass timber project. So they can join the table and form a part of that IPD team right at the beginning. The team can also add parties after the contract is executed, and the CCDC 30 allows for that under a schedule, what it calls a Schedule C, added parties. But whether you join at the beginning or you join later, that contract, everyone is collectively a part of the IPD table, the big room. And the recommendation from the CCDC is to involve parties as soon as possible so that everyone can contribute kind of maximum value to planning and design. So I want to talk about the CCDC 30's 4 phases. The first one is the big one, or is a big one. Just want to make sure that you guys can see me here. Okay, so validation. So after signing the contract, the validation phase involves collaborative project planning to determine project viability within the owner's budget and within the owner's schedule. This includes transparent disclosure of profit and cost expectations of the people at the table. This phase allows the IPD team to bond and culminates in the delivery of a comprehensive validation report. So the validation report will be used by the owner and the team to decide whether to continue with the contract or to terminate the contract. So you want to think of the validation phase of this CCDC as a think slow, act fast approach. So you're doing some deep planning up front, and it can take months. The validation phase can take months or more. You're doing that deep planning up front that should theoretically allow for a smoother execution or construction at the end of it. So it involves pre-planning the project to an extraordinary degree. It's gonna, in order to kind of assure the IPD team and the owner, particularly the owner, that there is a reasonable prospect of success within a realistic budget. The validation will likely require assessing the site, assessing challenges with governmental approvals, developing a design to a degree where the parties can arrive at the budget, a realistic budget. And during this validation phase, the IPD team will work together to achieve project objectives by preparing certain contract schedules, including the added party schedule I mentioned to you, as well as a schedule called the profit pool distribution schedule. This is known as Schedule D. And I just want to talk to you very briefly about that profit pool distribution schedule. The profit pool is the combined profit expectations of the consultant, the contractor, and the other IPD parties. Unlike traditional contracts, where profit is kind of baked into each party's price, here it's pooled and it remains at risk until the project meets its objectives. This mechanism of the profit pool distribution incentivizes the parties, or is supposed to incentivize, the CCDC thinks, the parties to optimize the project as a whole rather than maximizing their individual margins. So in preparing what is called the base target cost, I'll just call it the budget, the parties also specifically address project risks, their probability, including their probability, and their estimated cost. You price them out, the risks, one by one. All of this culminates into a validation report happening at the end of the validation phase. And the report is a written roadmap that captures the team's joint assessment of the site's performance, the risks, the cost, the schedule, the plan to complete this project. And if the report is accepted, the project is deemed ready and viable and can move to phase 2, design and procurement. So I want to talk to you briefly about the design and procurement phase if validation is successful. The design and procurement phase 2 of the CCDC 30 is basically the design portion. Now, the design was partially already developed in the phase prior validation. But here it's refined and it's completed, including specifications and detailed drawings. Long lead items like mass timber, the mass timber itself is ordered. All of the added parties are brought into the team. You might be bringing in your electrical, your mechanical, etc. And then the parties also establish a final budget called the final target cost. That budget is supposed to be lower than the budget in the validation phase. And setting that final target cost is a condition precedent or something that must be achieved prior to commencing the construction phase, which is the third phase here. The construction phase is just where the project is built. And the team, that table, the big room, maintains a high degree of collaboration during construction even. At the end of this construction phase, the project management team verifies ready for takeover, which transitions the project into the warranty phase, the final phase of the contract. So the warranty phase, I'll tell you a bit about it. At the warranty phase, that begins at ready for takeover, and it typically runs for a year unless there's something else worked out in the agreement with the IPD team. And the IPD team stays together still for this warranty phase, although the meetings will likely be much less frequent. The cost of any corrections that have to happen at this phase comes out of the project budget, and it can reduce the profit pool, which gives the team an incentive to do quality work at their stage the first time. Okay, so I'll end talking about this, the CCDC 30's phases by letting you know a little bit about how people get paid, because that's important. So there are defined, quote, reimbursable costs under this contract that are paid to the design and construction team in performing their work. Those costs include overhead, but not profits. So the owner is responsible for payment of those reimbursable costs, irrespective of the project outcome, and those reimbursable costs can be paid throughout the phases. Now, when do you get paid profits? Profit can be paid at milestones as well throughout the project, beginning in the validation phase. but only if the project is on schedule and if the estimated costs are below the target costs. At the end of the warranty phase, there's a final accounting. And if actual costs are below the final target cost, that final budget we talked about, the profit pool swells. It increases. If the costs exceed the target, then the profit pool shrinks accordingly. So let's go to the next slide. I just wanted to talk to you briefly about some of the considerations that are important to think about if you're considering a CCDC 30. This method really requires experience from the parties at the table, and preferably experience with working working together, not only on IPDs, but also working together as a team. That's a really big benefit for this project delivery model, and that might be difficult to achieve or to find. For projects using mass timber, a team member might have experience in mass timber, but not experience in a specific project type or in IPD. But they may also, have no experience working with the people at the table. And it just, you've got to keep in mind that there might be more conflict there. Another consideration is that IPD contracting requires upfront conditions and lots of tracking to ensure that the project is on budgets, on schedule, and that everybody understands whether they're achieving success and whether they are executing the project scope or not. So it requires quite a bit of administration and tracking of success markers, and that is an additional effort that you might not have to the same degree with other project delivery models. And then I'll also mention cost certainty. One potential drawback is you might not know how much the project is ultimately going to cost. With traditional construction, owners often use competitive bidding. So to get contractors competing on a price, you pick someone with the lowest price, you pick the lowest bidder, and then what the price is going to be. With the IPD, the focus is more on collaboration between the IPD members rather than picking the lowest bidder. So if the project goes beyond your budget, the owner ultimately has to cover the additional costs. They have to cover those reimbursable costs. And this can be a concern for mass timber projects because, materials, prices, availability, fabrication costs, all of those things can be unpredictable. And one last thing I wanted to mention here, I know we don't have a lot of time, is to also let you know that the CCDC has flagged that, it's possible that an owner could use the validation process as a kind of backdoor feasibility study to see if something like this could work, but have actually no intention of actually building anything. And the CCDC has flagged that as something that would be unethical for any owner to do. But it is a risk that's out there. Okay, so can we go to the next slide and then skip over to the next one? We do have a brief slide on the P3 model. So P3 models are multi-year, often multi-decade contracts in which a corporation or a consortium of corporations assume responsibility for activities previously undertaken by the public sector, by governments. So these responsibilities include the design, everything from the design straight through to management of the asset once it's built, and in some cases ownership, at least temporary ownership of the constructed asset at the end. So this is commonly used in large and complex public infrastructure projects. So you'd think highways, hospitals, courthouses, that sort of thing. One of the positives of P3s is because the same parties who build the asset are often maintaining the asset or have temporary ownership of it. There is a motivation there towards, you'd think, towards quality construction and focus on the whole life value of the asset or the long-term stewardship of that asset. On this slide, you'll also notice that the funding provider is there. That's a key portion of the P3 model, as the private sector normally will find private financing for the infrastructure. So we can go to the next slide. And just to highlight for you, before we get to questions, is some of the things you need to keep in mind for P3 models. There has been, there is a concern that some P3 models result in a loss of public control over delivering public services. So the private sector company getting involved sometimes results in that, and that's a concern for some people. There's also a procurement process at the beginning of P3s that can be very expensive, and that some of those costs can be passed on to taxpayers. And then one last thing I'll mention on this slide, as we're running out of time here, is the fact that securing private funding for infrastructure projects can result in very large financing costs, sometimes into the hundreds of millions, over the course of a decades-long P3 contract. So those financing costs can sometimes get passed on to taxpayers as well. Okay, so those are my comments on P3. I know we've gotten some questions. We have some questions already. So I'll see what do you think, Catherine? Do we want to address the questions that we have here, or do we have time to see what we have out in the audience?
Let's do one of each. So we've got some questions already, and one of the questions I'll just address it first. You can chime in, and then we'll maybe just pick one because it's pretty close to 2 o'clock. One of the questions that we received had to do with the role of the consultant, and this is one of the pieces that kind of really illustrates very well the point I was making about how the CCDC contracts can be like a little bit of a square peg round hole, at least the way they are now, as it relates to mass timber projects. So, we've now got a situation in mass timber where you've got like the manufacturing piece is going on at the manufacturing facility, and then there's work going on at the, sort of the project site. So if you look at the duties and obligations of a consultant under, let's say CCDC 5B, for example, they have to visit the place of work, that's a defined term, at regular intervals to assess the progress of the construction, and then they receive and review the applications for payment from the contractor and then their subs, and then they submit applications for payment. The consultant reviews the application for payment from the contractor, and then they assess the price of the services and materials supplied to the place of work. But the place of work, as it's defined in CCDC 5B and also CCDC 2, is sort of the project site itself. So then how does that work? Who bills for what when, and what is the consultant supposed to do when there's all this manufacturing going on at a different location? Is it as simple as amending the place of work to be both? That seems a little potentially fraught with unintended consequences. But again, in your unique situation, you have to kind of think that through. It probably makes more sense to like not have the place of work be both, but to have some kind of supplementary condition that amends, so that even though the place of work, the language is what it is, it's just revised so that the consultant also certifies the value and the applications for payment relating to the manufacturing issue. So it's something that can be very easily worked out, but it's got to be thought about ahead of time so that you don't wind up with a situation where the consultant's like, no, my obligations under this contract are to attend at regular intervals at the place of work and to receive the applications for payment and to certify the price of the work at the place of work, right? So these are just some examples that that involve a consultant as it relates to payment. So it's 2 o'clock, Diana. I'll let you make the decision. I know probably we're going to lose a few people because they've got other commitments. So we're happy to take another question, or we're happy to wrap up, whatever you like.
Yeah, I think if there's any more, if there's another question, please feel free to raise your hand and we can have that answered. Um,
The other thing I just mentioned too is that I know that because we're at 2 o'clock, if we are happy, Kathy and I, to take any questions by email as well. If you'd like to reach out to us to chat about anything in particular, within reason, we're happy to have your questions that way as well. So if we can just toggle back to the first slide, just so everybody has our email addresses.
they'll also receive your email addresses because we'll be sharing the slides with them. So they'll also find it there. They'll get the slides this week.
Oh,
Okay.
excellent.
All right.
I do wanted to just, you don't have to, you can leave this slide there. I just wanted to just mention as well, while we're looking for questions, I don't know if anyone put their hand up.
No. Yeah.
I would just mention that we did get some other topics that we received interest on that folks wanted to talk about, and we would be happy to discuss another time. Some of those topics include, lien rights and the annual release of holdback provisions in Ontario and how that could intersect with mass timber. So there's a question, for example, of whether a non-statutory holdback or deficiency security can assist with mass timber projects. There was also a question of when lien rights arise, when they end, and for whom. As well as alignment with provincial prompt payment provisions. That was a kind of a hot topic. People were interested in insurance planning and talking about bonded warehousing. So that would include kind of CBSA, international bonded warehousing, if you're getting your mass timber from overseas. So these are all interesting and important questions that perhaps we can address at another time.
Okay. All right. Thank you,
Thank you
everybody,
so
very
much.
much. Yeah. Thank you.
Thank you, guys.
Thank you,
Thanks,
Amelia.
Amelia.
Thank you, Catherine. And thank you, everyone, for joining us. I hope you all have a wonderful day.
Thank you very
Take
much.
care.